Thanks to Harvey and Jang for organising this webinar, and thanks to the audience tuning in to watch across a range of time zones around the world. My name is Michael Sexton from Geoscience Australia in Canberra, and I'm the chair of the EarthResourceML working group. It was the shortest day of the year yesterday in Australia, so hopefully from today onwards it's only getting sunnier. And that little image in the title slide is from the month in 2020. We had both choking smoke haze and tennis ball sized hailstones, which destroyed many people's cars at Geoscience Australia, including my own. This was before the pandemic was declared, so it was a sign of things to come. So I'll give a brief history and purpose preamble to EarthResourceML, how we got here and what we're intending to do with it. EarthResourceML is a markup language, which is the ML part, for the delivery of mineral occurrence, deposit, mining and resource data. Initiated in 2006 as a collaboration between Australian state and federal geoscience agencies to develop an agreed standard for delivering their mineral resource and deposit data. The name EarthResourceML was adopted in around 2009, and the working group was formed in 2010 under the governance of CGI IUGS. And so far, there have been 2 versions released, with a 3rd in development for the full model, and 2 light versions have been released as well. The brief technical background, ERML is an extension of GeoSciML, as Eric said in his previous talk, a mineral occurrence being a subtype of a geologic feature. GeoSciML, as Eric explained, extends GML and is an XML-based standard. The mining types of EarthResourceML are not part of GeoSciML. They are separate, and this is an important thing to note because it demonstrates the separation of the 2 concepts that kind of govern EarthResourceML, or two domains. And it's important to note that while it's an XML-based markup language, we do not necessarily need to think about the standard in that way, which Eric kind of touched on in talking about JSON. What do we mean by earth resource? I think most in the audience would know that earth resource, we're talking about a commodity found in the Earth's crust that can be reasonably assured of extraction. But in the context of who is consuming the data, earth resource can be governed by multiple different perspectives. So it's the intersection of many domains. The first one we all know and love is geology, but earth resource has products and economics that drive it. And it also has environmental implications. So what's left after something's been mined, or what are the byproducts of mining, or the waste products. And then there's the social implications, which no data model can really strictly touch on, but things like jobs and livelihoods, which maybe a step above economics, govern that. So these things can kind of be modelled, and we do. This is an example from our OSMIN database here at Geoscience Australia. This is how we model our deposits to our resources and commodities. We also model our deposits just here to processing plants and ownerships to companies, which are all linked together. And this is not strictly geological in any sense or scientific. This is more about process and operations. And here, it's a bit hard to see, this is our new alteration assemblages model, which is essentially strictly geological. So in our OSMIN database, we have a number of different parts of the whole database and the data model, which are essentially different domains and have different concerns and different perspectives. So what does ERML achieve? It's a minimum set of features and attributes for describing and communicating information about earth resources in a standardised way. It's very extensive, so minimum sounds like it's small, but it's not. It's quite large and complicated. But every time you introduce something new into your understanding of earth resources, you realise that you need to extend your model or change things in a certain way. And the other part is of the EarthResourceML working group is it's a collaboration between data managers and geoscientists across the world to better understand how we can model our earth resource data. And this second point is very important because through this working group, we at Geoscience Australia have introduced many of the ERML concepts into our database. So participating through this process has been valuable for us, not just by having something to produce to the standard, but by integrating the standard into our own understanding of the data. So the ERML model begins with 2 main feature types. The first being the earth resource, which is a subtype of GeoSciML's geologic feature, which is the object highlighted in green. The earth resource type is itself subtyped into a mineral occurrence, which is just here. And it is controlled by a vocabulary which defines whether that mineral occurrence is a deposit, a mineralized zone, or just a plain old occurrence. And these two are the same type, just in case there's some confusion. And an earth resource, so here's a basic example of how an earth resource relates to its resources. So you have your ore measure here, your commodity measure, which is effectively your grades, and this kind of maps to what I displayed before from our model in Geoscience Australia in our OSMIN database. So this is the standard and this is our internal model, and we can map these fairly well. The next important feature type is the mining feature, which has three subtypes: the mine, mining activity, and mining waste types. The mine type is somewhat self-explanatory, being the mine site where the mining activities take place. The mining activity is separate in a way. It's essentially maybe separate pits or seams at different depths which have different mining processes used to extract the ore. And then mining waste, which is something we don't do at Geoscience Australia, but we don't have the data on it, but we do have a project this year to gather that data, and EarthResourceML will be influential in developing our internal data model using what's been shared from people in the Inspire directive and our partners in the EU. So we don't have to start from scratch when we're thinking about how we model mining waste. We can use this as a very strong influence. Put together, so this is the complexity of just one part of EarthResourceML, and this is the mining, the mineral occurrence component with all the relationships there. Where it overlaps with mining are these two things here. So there's a mining activity that works on a earth resource and a product that derives from that mining activity. And when we look at the mine centered model, this is how they integrate into the mining waste and such and such. Next we have ERML Lite, and Eric touched on these light versions of GeosciML, and there's a similar one for EarthResourceML. So the full ERML model is complex and involves multiple nested relationships that in implementation can create a latency and impedance issue when querying the database. Because we want to have a well-performing web map in our portals and responsive services, we developed a light version of the data models, and this targets the most representative features and attributes to be portrayed in a flat structure, much like a shapefile or a spreadsheet. So here we have our mineral occurrence view, our mine view, our mining waste view, our commodity resource view, and processing plant view. These are all basically flat structures of the nested relationships that we might want to target in a web service for doing basic web maps or easy spreadsheet downloads for consumers who just want to interrogate everything at once. All of our model is controlled by vocabulary. So where we have a set of agreed terms, the vocabularies, which we have 19 of, are applied, and they effectively restrict and control what we can place in the model for certain things like commodity or operating status of a mine or timescales. You can find the vocabularies by following this link here. This also contains the GeoSciML vocabularies. And as I said, it includes a whole range of things. So mine status, commodity, reserves and resource categories influenced by JORC and Trisco codes. Data delivery and implementation. This is the important part and often the hardest part. So there's the main vendor that we use is GeoServer, and we've got a lot of experience at GA, and there's a lot of experience in the community to use this. Also, there's map server implementations, and we have a number of portals which consume this data. This one is the Austin Geoscience portal. We also have GA's flagship Geoscience Australia portal, and there's also Minerals for EU consumes EarthResourceML data as well. ERML version 3, so it's still in development, very near to completion, although completing it is proving difficult. It improves the resources model to represent resources as reported by the mining companies. So there was a bit of looseness in how it was modelled, and now it sort of strictly links everything to a company report, which is generally how we get the data. Addition of processing plants to the model, and removal of mandatory attributes and relationships, which was imposing an unnecessary burden on delivering the model. As Eric spoke about, there's GeoJSON and JSON LD. So EarthResourceML began its life as an XML-based standard in 2006. That same year, a change in web paradigms, Web 2.0, as it was known, introduced a new data transfer format called JavaScript Object Notation, or JSON or JSON, depending how you pronounce it. In the years since, this has become the preferred data format for web developers to use when they separate their content or their data from their application design. And XML quickly became unfashionable for a number of developers. There's two main implementations as far as I understand it. GeoJSON, which Eric touched on, and JSON LD, which is JSON is just an extension of basic pure JSON, and it's similar to KML, and it's the way it works. One of the problems with it being only WGS84 is the same as KML. So it's limited to the coordinate reference system it can use. JSON LD is a linked data implementation of JSON. This is essentially inheriting or borrowing concepts from XML and putting it into JSON. And my personal opinion of this, and others may disagree, is that JSON's appeal to web developers has been its lack of strictness and verbosity. And JSON LD may not get any better uptake than XML, so it's possibly chasing down a path that it shouldn't go, and we should, those of us interested in that should concentrate on XML because it does that kind of thing better. So the future, EarML version 3, competing priorities and the continued pandemic get in the way. GeoServer feature templating and smart data loader, which was touched on by Mikhail before, and last week I attended a session with people at BRGM and Geosolutions, which demonstrated this, and it seems like it will really lower the barrier for entry for developing these kinds of web services, and offers significant performance improvements. And JSON outputs, this will hopefully, as much as JSON is a bit of a toy data structure, it will hopefully get uptake from the kind of people who will just want to consume the data and don't want to think about the structure and strictness and things that are imposed by an XML-based transfers or data transfer standard. So contributing, we have a website, which is earthresourceml.org. We also have a mailing list. EarML@googlegroups.com. Please sign up. You just have to email. You don't get spammed. You're lucky if you get an email at all. Or contact me at michael.sexton@ga.gov.au and visit any of these web portals. It's not exhaustive. There's some I had to leave off for space considerations, and that any of these will do. And thanks a lot.
Thank you, Michael. Well, there is discussion in the chat, in particular about JSON. And so, for example, Simon Cox mentions that JSON LD is still JSON, just with a header that allows it to be interpreted as RDF. And Eric added, JSON is basically tight coupling server and client application. You changed your mind, Eric. And Simon says you can ignore the header. So good discussion there. Any specific questions for Michael Sexton? General discussion. Go ahead in the chat or unmute and go ahead. Discussion.
Chat, Harvey.
Go ahead.
Do you have a reference implementation of EarML like in Postgres?
Do we?
Yeah, do you?
We have an implementation on our services. I wouldn't call it the reference implementation, but I'm not sure what you mean by reference in Postgres.
Something that people can just download and upload in their Postgres to have an EarML database or compliant database. So I remember for GeoScience, Alistair created one, so people could just be up and running with their data, and it's pretty close to what the EarML would be, so it's easier to map up.
I wouldn't call what we've got a reference implementation. In fact, I would like to rewrite what we've got in terms of the database structure and the model. So the answer to that's probably no. But it is when we have perfected what we want, I think we would release it as a reference implementation. So yeah, that's a good idea, just to get people started. But hopefully things like the Smart Data Loader make it a much easier thing to model, rather than having to think about how to map things in a app schema mapping file. This question from Frank Featon: is it possible to bridge EarthResourceML with GeoSciML? As I understand it, yes. So correct me if I'm wrong here, but I believe these things can be linked. We don't do it at GA, and I haven't seen it done, but I don't see any reason why it can't be done. If anyone wants to correct me.
And because, well, EarthResourceML is an extension of GeoSciML. So
Yeah.
It adds more classes to GeoSciML. So you have a GeoSciML representation, you just embed EarthResourceML GeoSciML representation.
Yeah.
So everything in GeoSciML is reusable from ERML.
Yeah. It's just a specification in the one of the map feature specifications. So it's not. Yeah.
Okay, more general discussion, please. Who'd like to go next? Or questions or suggestions for Michael? Or anything regarding Mikhail Beaufils' presentation or Eric Boisvert? General discussion about markup languages and related topics. Okay, going once. General discussion, please. Going twice. Mark Rattenbury, you're ready.
Indeed I am.
Indeed. So Michael Sexton, thank you very much for that very helpful overview of EarthResourceML. So now Mark Rattenbury, please go ahead.